welcome back. Let's review now the solutions and answers to the problem sets for Lesson 3. So you had a table here to complete to find the new temperatures in the afternoon. Please note that our morning temperatures would obviously have been our starting points. So looking at those starting points, we want to make sure that we are determining whether we are rising or whether we are falling on the thermometer or on a vertical line, number line. So taking a look at that, let's take a look at 2 degrees. There was a rise of 8. That means I'm increasing, I'm rising, I'm going above 8 with 8. So 2 plus 8, which would equal 10. So my afternoon temperature is 10 degrees Celsius. At -2, pay close attention that this is actually a fall. So I'm going to show you right here that I have made a number line, and I'm starting at -2. And from there, I'm falling. And remember, if you're going below, that is a negative number. I'm not increasing in number, I'm dropping in number. So my new temperature will be -8. My equation is -2 plus -6 equals -8. And I've just put those extra parentheses around the negatives. They're not required, but if it helps you keep those numbers straight, then that may be a good practice for you. -4 degrees, and I rise 7. So -4 plus 7 equals +3. -4, rise 7, +3. So the afternoon temperature is 3 degrees Celsius. At 6 degrees, the temperature falls 9 degrees. That means I'm dropping, and it has to be a negative. As I make that drop, you can see that it's going down. And my final temperature is -3 degrees Celsius. 6 plus -9 equals -3. And again, you could put this in parentheses if that assists you with seeing that as the negative. -5, and it falls 5. So -5 plus -5 equals -10. And here would be a visual using those arrow diagram or showing your vectors. And the last one, I'm starting at 7 degrees, and I fall 7 degrees. So my final result is at 0. So let's take a look at this. My equation would be 7 plus -7 equals 0. And think back to that 0 pair. Remember, when the two numbers you're adding have the same absolute value, and one is a negative and one is a positive, they cancel or form a 0 pair. It's kind of like if I give you $7 and I take $7 back, I gave you nothing, it'd be 0. Moving down below, Terry selected 2 cards with the sum is -10. So can both my cards be positive? No, they cannot, because positive numbers move from the right of 0, so they're already positive, and they keep moving right. Therefore, they cannot have a solution of -10 or a sum of -10. Can one of the cards be positive and the other negative? Sometimes you have to just test this and see. And the answer is actually yes. So when can you get a positive and a negative that has a negative answer? Well, in this situation, if the negative arrow is 10 units longer than the positive. So for an example, to assist you, if I'm at +4 and I move to the left, -14, notice there's a 10 difference here in length, okay? Then I would end at -10. So you can have a positive and a number, but there has to be at least a length of 10 difference with the negative number. Okay, and then for 2C, what about them both being negative? Yes, absolutely, that would work. Not always, it depends on the numbers to equal -10, but two negative numbers will always give you a negative number, as you can see in this example. So moving on to the next page, let's take a look at number 3. I'm a visual person, so I like to show my cards. -8 plus -10 equals -18. Notice your vectors. And that would be proof or justification for your answer. If all you did was put your answer down here, then you did not justify your answer. So make sure you're giving a visual through picture or explanation. Now on B, I want to know the distance from the 8. So if I am right here, what is my distance here? Now remember, direction doesn't matter when you're talking about how far or the distance. Okay? So think about the second number here of -10. I'm finding the absolute value. So the absolute value of -10 would give me the distance of 10. On C, I took that -10 card away and I drew a +10. So I have -8 plus 10 equals 2. There is my justification. And I'm showing the +2. I do want to point out with these two problems right here that they both traveled a distance of 10 from -8. But they ended on different sums because they went in different directions. But the distance traveled of 10 and -10 would still be the same absolute value of 10. And you can notice that from the distance here and the distance here being 10, or I actually showed it on here. These two distances would be equal. All right, let's go down to number 4. If I'm starting at 67, so you're sitting at 67, and I'm moving -35, how far am I moving? It doesn't matter which direction. Okay, the fact that it's left. If I need to know the distance, how much distance will I travel from 67? Again, the absolute value of this number will give you the distance. Remember again, a negative number moves in the left direction, but the direction doesn't change the distance. Okay, and our final problem, being very, very cautious how you try to put this together. The sum of -4 and a number is 12 units to the right of -4. So I'm at -4 and I need to move 12 units to the right to get to my sum. So -4, 12 units to the right, and I end at +8. And there is my justification on my arrow diagram. If you found that you got a couple of these problems wrong or you struggled, please look back over, make sure you've made notes and corrections, and reach out to your classroom teachers for extra help if you had any difficulties, because we definitely need this information to be solid as we move forward. Thank you.